Alright, this will be the last video on linear combinations. I just wanted to add in an example that involved maybe a couple of extra steps. So we can see here, one, that I almost misspelled linear. I had to squeeze that A in there. Liner combinations would be something else entirely, I'm sure. But here we're given our F and our G, and they're asking us to double our vector F, triple our vector G, and slam those two things together so that we can come up with a resultant vector of this kind of hot mess that we've got going on here. Now, if you've watched any of my other vector videos, you'll know that I'm a big fan of component form. I think ultimately it's the way to go to solve many of our problems. So what I want to do first is just go ahead and convert these over. I'm going to be a little sloppy and just kind of go ahead and round these things off to a couple decimal places for this video. Keep in mind that depending on the problem you're working and the reason you're working through a certain problem, you may have different needs for rounding. You may need to be more accurate than you are here. My hope is that you remember component forms are easy to get by taking your magnitudes and multiplying them by either cosine or sine of the angle you're given, depending on if you want to find x or y respectively. So here, for example, we're going to do 14 cosine of 130, and here we're going to do 14 sine of 130. And this is going to give us our x and our y component for our f vector. G is going to be the same way. We're just going to swap out the numbers that we have here instead. So we're going to use 13 and 200 for both of these. And my hope is you'll see as you work through more and more of these types of problems, all this becomes really second nature. I'm writing this down to have that visual aid to kind of help guide through the video, but normally I would just pick up a calculator immediately and I would just type this stuff in. I already know where I'm going with these problems most of the time, so there's no reason not to. Now this one, I was going to do two decimal places, but noticing this negative 8.999, I'm feeling okay by approximating that as negative 9. I'm not usually a fan of rounding that clearly and cleanly, but there's no real reason in this case for an example not to just go and let that slide. Here I'll be a little more careful, and I'm going to call that 10.72. So 10.72. And I like to go ahead and think about whether these numbers make sense. Since I didn't check degree mode in my calculator, there's a chance of things going wrong. 130 degrees is in the second quadrant, and that's where you have negative x's and positive y's, so I feel pretty good about the answers I've gotten here. And 130 is also very close to 135 degrees, where your x and y components would actually equal each other in magnitude. So seeing a 9 and a 10 tells me I'm pretty close. So I'm going to go over here now. We're going to repeat that process. We're going to say, Mr. Moffat, stop rambling about everything. We get negative 12.22. And then I'm just going to do second enter and slam a sign in that place instead. And we're seeing approximately negative 4.45. So these are rounded values. If you do the problem slightly differently, you might get some other things to happen. What I'm seeing here is that we have both negative x and a negative y, which 200 degrees, if you don't know, 200 degrees is in the third quadrant. So I know for a fact that we should have a negative x and a negative y there. So these numbers are all feeling pretty good to me. I don't feel as though anything's off, and I'm pretty well ready to go ahead and run through this. So I want to take 2 times my f vector, so that's the negative 9, and the 10.72, and I'm going to add to that 3 times my vector g, which is negative 12.22, and negative 4.45. Once I've worked through that, I'm pretty much good to go. So here we are. We know this one's going to be really easy, on the first component at least. Just doubling a negative 9 is not too bad. If you don't like decimals and you prefer, you can just do what I'm about to do and just type some things into the calculator for the sake of brevity. We'll see that 10.72 doubled is 21.44. So 21.44. We're going to add to that 3 times this stuff. Now this is really easy to multiply by 3 because they're all tiny numbers. So we're going to get negative 36.66. And then over here, maybe you don't like those numbers quite as much because there's some overlap. So we'll just go ahead and do 3 times that negative 4.45. And we're going to see a negative 13.35. From there, we're just going to combine these things. You add your x's, you add your y's. Since I had the y component still in my calculator, I'm just going to go ahead and add to it the 21.44. And we see 8.09 as our resultant y component. So I took this y component and added it to that y component. And then we just want to take our x components and add them together. I guess that one wouldn't have been bad to add by hand, but here we go, 54.66. We see, again, so we said negative 54.66. Make sure to put the correct component in the correct spot. I almost wrote down 8.09 first. I warned against that in a previous video, and I still almost did it myself. So here's the issue that we have now. We have found the vector 2f plus 3g. This would be an acceptable answer if they wanted component form. That's what I've done in previous videos. But notice that they gave me both magnitude and direction for each of our vectors, and we did not specify the form we wanted. Most of the time in a problem, we want some semblance of conformity, and that sounds awful in some aspects, but the idea is to be consistent. So if they have given me a certain form, and they haven't specified to use a different one, I'm going to assume that they don't want this component form, and I want to go ahead and convert this back to this form up here. Now, if it specifies, if I had said up here, find this thing in component form, then I would be done and I'd be okay. But don't forget that, especially the magnitude, but also the direction, are pretty easy to come up with. The magnitude is a result of Pythagorean theorem, so we take both of our values, thinking of them as the sides, the legs of a right triangle. We'll just add their squares and take a square root, and we'll get the hypotenuse. So we'll do that here in just a moment. And then to find direction, all we have to do is analyze our angle using inverse tangent of our y component divided by our x component. It's important to keep in mind as well here that this tangent angle may not be the one that we want. So I'll put a little question mark here, and we'll just take a look at it here in a moment. So let's go ahead and find that magnitude. That's going to be the easier part to be comfortable with. Really, you don't need that negative there, so I'm going to type it this way. If I square a negative version of this number, a negative times a negative does result in a positive, so maybe save yourself some stress here. Anytime you're finding the magnitude of a vector this way, you really don't have to worry about the negative components. We see a magnitude of about 55.26 degrees. And now for me, I like to round to whole numbers, so maybe you just call that 55 degrees. For angles anyway. I don't like whole numbers for measurements usually. Let's go ahead and do inverse tangent of 8.09 divided by negative 54.66. We're just going to see what we get here. So I'm saying about negative 8.42. Oh, that's what okay, I'm glad that I caught myself here. I put degrees there because I was already thinking ahead, but this would be really nice to keep at 2 decimal places. This was not a degree measurement. This was a magnitude, so I'm glad I caught that. Down here, we are finding our angle. So we found a negative 8.42. If you've watched previous videos, you know that that would be something down here, when in reality we want the opposite direction. We want the thing that's out here. That's because we have a negative x and a positive y to work with. So all I want to do now is add 180 degrees to my result. So I push myself into the correct quadrant. And I'm going to see that my theta is actually about 172 degrees. I'll round that up just to be a little on the lazy side of things. And so, being careful not to be dumb and put the wrong thing on the paper like I just did, we're going to go in here and just say, okay, our 2f plus 3g is the vector with a magnitude of 55.26 and a direction angle of about 172 degrees. And that would be a sufficient final answer here.